Okay, welcome to another video on geometry. Our objective today is to identify the midsegments of a triangle and use the properties of the midsegments. Okay, so and this is from chapter 5, section 4 in your geometry textbook. Now, so copy that down. Press pause if you need to. Now, what's a midsegment? Well, a midsegment is and we should write down a definition. A midsegment is a segment that connects two midpoints of a triangle. The midsegment of a triangle, at least a midsegment of a triangle, is that connects two of its midpoints. I'll show you. Here's a triangle. This is GeoGebra, and it has a little thing where I can find a midpoint. I think I can just, boom, there it is. So there's the midpoint of that line. There's the midpoint of that line. There's the midpoint of that line. So a midsegment just connects any of those two midpoints. So that's a midsegment. This is a midsegment. And this is a midsegment. So if you draw all the midsegments, you get a midsegment triangle. Oops. And midsegments have two properties. First, they are parallel to one of the sides of the triangle. So, for example, this midsegment is parallel to this side. This midsegment is parallel to this side. And this midsegment is parallel to this side. And the second property is they are half the distance of the side they are parallel to. And so like this was half this. This is half this. This is half this. One way of thinking about that is just imagining, like, since these are, like, let's say this is 20, just for example. If BC was 20, then, and imagine it, if this shape was actually a parallelogram and you just thought of it as like, or a trapezoid, and you thought of this as the opposite side, but it's just, the opposite side happens to be 0, right? Like, I mean, it's not a trapezoid, but you can sort of think of it as a trapezoid. In fact, maybe I could draw a trapezoid that's kind of similar just to show you what I'm talking about. I could draw something like this. Like this, but instead of going all the way, like, so this is like this, but this one is actually like here, this side is like 1 or 0.5. But here it's like a trapezoid, but that side is 0. So it goes from 20 to 0. Well, halfway from getting to 20 to 0 is the midsegment. That's the halfway point, and there it's 10, right? Right in between 20 and 0 is 10. So I'm not sure if that helps make sense of it, but basically the rule is the midsegment is half the distance of that side they're parallel to. And they are always parallel to a side. So, okay, got to know that. Your book here asks you, show the midsegment is parallel to JK. So how do you show things are parallel in the coordinate plane? Well, parallel lines have the same, if you said slope, good job, the same slope. So we know the slope of this line, it's up how many, over how many. You could use slope formula, but I'm going to do it visually. It's up 2 over 6. So its slope is 2/6, or 2/6, which equals 1/3. And just to be clear, I'm not talking about the distance, I'm talking about the slope. How steep is it? Well, it's up 1 over 3, up 1 over 3. So what about this midsegment? What's its slope? Well, it sure looks like it's up 1 over 3. So its slope is also 1/3. 2/6 and 1/3 are the same. So we just showed that it's parallel. Check. But now we have to show that midsegment is MN twice as long. Did I copy that down wrong? Half as long. Yep, I copied it down wrong. I beg your pardon. Cross this out. And I'm going to write half. So MN is half as long as JK. So again, now how do we show that? Well, we're talking now we're not talking about slope anymore. We're talking about distance. How far apart, how long are they? What's the distance from J to K? Well, for that we're going to use the distance formula, which is really the Pythagorean theorem. The Pythagorean theorem says that this squared plus this squared equals this squared. And we know the vertical segment here is 2 and the horizontal is 6. So 2 squared plus 6 squared equals JK squared. That means 2 squared is 4, 6 squared is 36. So that means 40 equals JK squared. So JK must be the square root of 40. So let's remember that on the next page. We'll have to compare MN to square root of 40, right? Okay, now MN, we're going 1 and 3, right, when we travel along here. So 1 squared plus 3 squared equals MN squared. So 1 plus 9, or 10 equals MN squared, right? So MN is root 10. Well, now is root 10 half of root 40? Well, to answer that, we're going to do something to root 40. Maybe some of you can vaguely remember what we're going to do here. Whenever we have something under a radical, we ask ourselves, can we factor out any perfect squares? In other words, a perfect square would be like, oh, the square root of 9 is 3, the square root of 16 is 4. So those are perfect squares. The square root of 7 is not a perfect square. So can I factor out what are the perfect squares? Well, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36. You guys get the idea. Do any perfect squares go into 10? No. 4 doesn't go evenly into 10. No, they do not. Do any perfect squares go into 40? Yeah, 40 equals square root of 4 times 10. And so we can take that square root of 4 and make it 2. But we leave the 10 inside because that's not perfect. So if MN is root 10 and JK is 2 times root 10, then we've showed that MN is half of JK. Because if you multiply MN by 2, you get JK. All right, one more example. But again, what we just showed were the midsegment properties, that the midsegment has the same slope, is parallel to one of the other sides, and it is 1/2 as long as that same side that it's parallel to. All right, the next and last example I think we'll do is given that UW and VW are midsegments, find UW, like what's its length, and find RT, what's its length. Okay, first UW. Well, what helps us? What theorem helps us? What theorem from here? Which one of these theorems helps us? The fact that it's parallel, a midsegment is parallel to one side of the triangle, or the fact that it's half that distance? The fact that it's parallel doesn't help us. The fact that it's half that distance helps us. UW is parallel to RS, and it's half that distance. So if it's half 12, then UW equals 1/2 12. And what's 1/2 of 12? Well, 6. All right. Now, what's RT? RT is over here. Well, what other information do they give us? Well, they give us VW as another midsegment. VW is half RT. VW is 8. So 8 is half RT. So in other words, 8 is half of what? Well, if we divide both sides by 1/2, we can find the answer. Now, to divide by a fraction, we actually multiply by the reciprocal. What's the reciprocal of 1/2? It's 2. And that makes sense. Without even doing all this algebra, we kind of can figure, I mean, you kind of knew it already. 8 is half of what? Well, 8 is half of 8 times 2. 8 is half of 16. So RT equals 16. All right, we're going to stop there, although you might want to take a look at example 3 in your textbook. It's on page 289, and it asks you, given the midpoints of this triangle ABC, given the midpoints L and N, can you find the points A, B, and C? And you can, but it's a lot of work. Maybe a test question down the road. All right, thanks for watching.